Hello there, math fans. I'm Dr. Andy Lovelace. I'm making this video based off of a question a student has asked me on my discussion board about this problem, and I apologize to this student. I'm going to kind of overkill this a little bit, but I think the confusion has to do with how we work with this fraction. And this kind of hits on a thing I've noticed. It's a huge stumbling block for many students. And so when I find something like this, I'm always trying to make some sort of resource that can hit on this. So this kind of hits a whole bunch of things. So we'll come back to this in just a second. Ultimately, this problem, this is from a Calculus 3 course, involves this. And if something like this helps anybody, please let me know. I'm always excited when I can find kind of something to illustrate an overarching principle I have seen that lingers through many courses. And I might be totally off base about what's confusing this student, but I do think this hits on some of the things I think about when I do this. So I think the confusion, and again, please on the discussion board, I'll post this, correct me if I'm wrong, is that, let me get this actually written correctly. So the student is trying to compute this. In order to be able to do the problem, they have to be able to look at this fraction and identify what's happening with y. They have to realize that the only y in the problem is right here. And so they're going to have to take their fraction and split it apart into pieces. Calculus students have to do this all the time. Take a function and rearrange it. And that got me thinking about this thing I do when I teach Calculus 1, where I have students go through this exercise and show me that they can rearrange their fractions in this way. This is really an overarching important skill. In order to use our calculus rules, we need to get to a point where we see this is the same as this without even thinking. It needs to be like breathing. We need to be able to look at this and say this is 1/3 x to the 16th. We need to be able to look at this and say it's 5/4 x to the 6th. We need to be able to look at this and say it's 1/4 x to the -2. So I really like this. This is an exercise actually from my business math course, but an exercise in freeing your mind and how you separate fractions. Okay, so that's important. So I'm going to say something. I'm going to get rid of this for a moment. And if that would be helpful, I can share that with more students. But I think it even goes further back, which is often if we're trying to remember a certain rule, then we're in trouble. So you can always throw the rules out and just do some arithmetic, meaning pick some numbers, whatever you want here. Even pick numbers that you know would cancel, and ask yourself, are these things the same? And the truth is, I think of all of this as multiplication. So if you're just multiplying and dividing, you can rearrange it to your heart's content. And you should rearrange it in your head so that things cancel. This is often a mistake I see students do. I tell students, if you write 18/3, it's right, but it's also wrong. Well, students got really mad at me last quarter when I said that. It is the correct number, but no one should ever write 18/3 here. Because if you know how to work with your fractions, you'd be rearranging them in your head and just saying 6. I've seen this rear its ugly head many times. So I've seen students get in trouble when they were trying to do something like 3 times 2/2. I've seen people do this and they don't realize they can rearrange, and I've seen students write 6/6 in a Calculus 3 course. So a misunderstanding about rearranging. So why am I saying all of that? I'm saying when I look at this, I immediately rearrange it without even thinking. I just say, hey, I would like to look at the y by itself. Is that legal? It is legal. This is just like my fraction. This is like my 6 and my 3. It's like if it had been 6y/7, I could have written 6/7 y. So that's a really important ability for calculus, to rearrange multiplication to your liking. Okay, so the actual rules are these. and this is what I was talking about. This is what part of this same review sheet in my other course. The ability to rearrange fractions to your liking, very essential in calculus. Things like this. It's good to be able to add fractions and knowing your exponent rules. I would say that, a large proportion of calculus errors have to do with working with these things. And so the more, when we realize that error like this happens, we should stop until we're really comfortable. And if I was a student, I wouldn't just blindly write down the rules on my note sheets. That's not going to help you. Include an example, include some comments to yourself. So that's how my review sheets usually look when I'm doing stuff like this. Okay, so back to this problem. Sorry to the student that asked this question, but I hope that was valuable because I think this just happens so much. So when I look at this problem and I realize I am trying to look at the variable y, and a lot of the comments I've been making so far are of a general nature. Now I'm jumping into calculus 3. So I had to be able to realize I'm multiplying by y. Whether I multiply it here or I multiply it in the numerator, doesn't matter. That really helps me because I can realize there are no y's here. So this is all just a constant. It's like I have a number sitting here. You could even just put a little box here and write the word number. So really all you're integrating is a number times y. It's like you're integrating 5 times y just to make something up, which most students would know that's the integral with a possible constant, but we have bounds. So when I go to do this problem, and I talk about in class that you could even move this out here. You could move the 6 all the way out if you wanted, but it just looks funny. So you're going to have 6 over 7x to the 5th plus 1. And then you're going to have 1/2 y squared, evaluated from y equals 0 to x squared. And then we're plugging this in. Again, the coefficients don't change. That's what this is out in front. We think of that as a coefficient. So once again, here's an example. In my head, I immediately canceled the 6 and the 2. How did I do that? Because I'm comfortable. I realize that when I look at that, it's like I have a bunch of multiplications. I have 6. Really, you could even, I don't know that this helps, but you could write 1 over 7x. That's one of the things we are multiplying. And there's a 6, and there's a 1/2. And we got to get really comfortable doing that. If all there is multiplication. So in my head, when I see that, this is 3. This is really an essential skill for success in calculus that I think we don't emphasize enough because most instructors just say, hey, we should know that already. And I think I'm trying to catch these things and make it really explicit. I can't often do this in class because it takes so much time. But anyways, if I plug this in here, now I'm going to plug an x squared in here. It's going to be an x squared squared. Now that's a different idea of knowing your exponent rules, but that's really counting. X squared means the same thing times itself. And this, so it's a couple little principles. And a thing I've been thinking about is when you realize you've hit one of these and you've made a mistake, that's a real important time to stop. So anyways, that becomes, and now I'm going to rearrange. I'm going to put it back on top. So what do I mean by that? Let's say something there. So I'm about to write, I realize at this moment I have this times x to the 4th. I've already taken out the constants. So when I write this, I'm going to write it this way. Again, it's that comfort. So I've just used the idea of rearranging my fractions. I don't know how many times here. 1, 2 when I got rid of the constant, 3 when I put it back up. So this is kind of, like I said, in the background of a lot of confusion students have. So that's why once I saw this problem, I thought maybe I'll just stop and talk about this. And again, that might not even be what the student's issue was, so I apologize if I missed it. But the last piece of the puzzle is an integration problem. So if this was your question, I apologize it took me so long to get here. But this is a substitution problem because that's an x to the 5th and that's an x to the 4th. And so we're going to have 7x to the 5th plus 1, we're going to have du is 35x to the fourth dx. We're going to have dx is 1 over 30. And people do this differently, but I'm not giving a substitution lesson here. So if I plug in a 0, I get a 1. If I plug in a 1, I get an 8. Hopefully the x to the fourths go away, which they do. That's the whole reason we did it in the first place. And for my students in my 126 course, I do have separate videos reviewing this if this is the stumbling block. And now yet again, I'm going to use my fraction skills. This 1 over 35, I'm going to rewrite 3 times 1 over 35, and I'm going to rearrange everything as 3 over 35. So you can see this is happening over and over and over again, these little fraction skills. And I may have made an arithmetic mistake. Do let me know if that's the case. But I hope you're getting the point. I'm not checking my work. I'm just talking about this idea. So then you would have 3 35ths, the log of u, evaluated from 1 to 8. And so you'd have 3 35ths, the log of 8, minus the log of 1, which is 0. So someone let me know if I have the wrong answer there. And I'll post a correction. I should do a double check, but I'm sure the video has already gotten too long. Mostly I want to talk about those fraction skills. So I hope that kind of helped. You saw the back and forth. That's something that it sometimes lingers, that students don't catch as an issue that's causing them trouble. And I hope that kind of hit on that point. Let me know if it did.